In this video, we are going to prove that the derivative of the square root of x is equals to 1 over 2 of square root of x. So according to the derivative, the definition of a derivative is a limit function. So the limit as h approaches to 0 of f of x plus h minus f of x all over h. So this is the formula. This is the limit definition of a derivative. So let's go ahead and substitute this. So we have our f of x is our f of x is the square root of x. So since it tells us f of x plus h, we're going to go ahead and replace that with square root of x plus h. And then minus our original function, which is the square root of x. So let's go ahead and put that. And then all over h. Now notice this. We need to rationalize this. So I can go ahead and multiply this by a fraction, which is the square root of x plus h plus square root of x all over square root of x plus h plus square root of x. I can go ahead and do that. Now notice this numerator. This is a difference of squares. This is a difference of squares. Because remember, the difference of squares is defined by a squared minus b squared. And that's simply a minus b and then a plus b. So if that is the case, then this is square root of x plus h squared minus square root of x squared. Because this right here, the multiplication of this is a difference of squares, and it satisfies the formula for the difference of squares. So let's go ahead and apply that. So since the square roots and the squares cancel, this leaves us with x plus h minus x. So x cancels out, so this only leaves h. So the final expression will become the limit as h approaches to 0, h all over h times times x plus h plus square root of x. There we go. There we have it. This leaves us to this expression. So we're going to go ahead and cancel h on both sides. Cancel h on both sides. So this becomes... where do I go? Okay, here we go. So we have 1 all over square root of x plus h plus square root of x. So apply the limit. So it says h approaches to 0, but we can go ahead and substitute it to 0. So we have 1 all over square root of x plus square root of x. Why? Because 8x plus 0 is just simply x. So we have 1 all over square root of x plus square root of x. So therefore, the derivative is exactly 1 all over 2 square root of x. So that's our proof. Pretty cool, right?